Alright, so today we're going to do 5.3, slope of a line, day 5 in your OneNote. Today's learning goal, I can graph proportional relationships using slope. So let's bring out our Cornell notes. And here we want to highlight the fact that the slope describes the steepness of a line in the coordinate plane. The slope of a line is the ratio of the vertical change to the horizontal change. So again, that's just like us doing rise over run, which we've been doing for the last couple of days. Identify the slope of the line. So remember, rise, we always want to look at the rise first. Our rise in our case is 2 over my run, 1, 2, 3. Let's look at the next one. My rise goes up 1, 2, 3, and my run goes over 1, 2, 3, 4, 5. The next one, we start from the bottom. Our rise goes up 1. Then our run goes 1, 2, 3, 4. But be careful, we're going to the negative direction or towards the left, so that means it's at a -4. So that means I'm going to put my negative at the beginning of the entire fraction. So -1/4. So one of your friends describes the slope of a line as the x-coordinate increase by 2, the y-coordinate decreases by 5. So remember, you always set up your slope as the change in your y over the change in your x. So as the x-coordinate increases by 2, that means that my denominator should be 2. The y-coordinate decreases by 5, which means it's decreasing by -5. Let's look at the other friend's description. They describe the slope of the line as the x-coordinate decreases by 2, the y-coordinate increases by 5. So again, let's talk about how we should set up a fraction. Our x-coordinate decreases by 2, so that means that we're going on the bottom. And our y-coordinate increases by 5, so that goes on the top. Notice how I brought my negative to the very front of the entire expression. So, is it possible for your friends to be describing the same line? Explain. Well, yes, because the slopes are the same. You can find the slope of the line by subtracting the coordinates of any 2 points on the line. The first y-coordinate you use for the rise must belong to the same point as the first x-coordinate you use for the run. So there's a formula for this. The slope equals the change in y-coordinates, which would be labeled your y2 minus your y1, divided by the change in your x-coordinates. So that would be your x2 minus your x1. And if you notice here, we can label our ordered pairs as our y2 and y1, meaning this would be our y1 and this would be our y2, and then our x1 would be up here and our x2 would be down here. We'll take a look at a few examples to see how this is applied. What is the slope of the line that passes through each pair of points? So remember, I'll put the formula here. M equals y2 minus y1 divided by x2 minus x1. So let's go ahead and label our ordered pairs. x1, y1, x2, y2. So let's go ahead and set up our subtraction. Our y2 is 4. Our y1 minus 2 over my x2, which was 2, minus my x1, which is negative 3. So now we can simplify this. 4 minus 2 gives me 2. Remember, if you have two negatives next to each other, you can add them. So 2 plus 3 gives me 5. So my slope to my ordered pairs is 2/5. Let's do the next one. x1, y1, x2, y2. Set up your fraction. y2 is negative 5 minus my my y1, which is 1, divided by my x2, which is 8, minus my x1, which is 6. So we get negative 6 divided by 2. So negative 6 divided by 2 gives me negative 3. This would be my slope. Let's try the last one. x1, y1, again label everything, x2, y2. So y2 is 4 minus your y1, which is 4, divided by your x2, which is 1, minus your x1, which is negative 2. Well, 4 minus 4 is 0, divided by, don't forget, two negatives, they make a positive. So we get 1 plus 2, which is 3. Well, 0 divided by 3 is simply 0. So that would be your slope. The line shown has an undefined slope. Use the points shown to explain why. So again, let's label them. x1, y1, x2, y2. Set up your formula that says m equals y2 minus y1 over x2 minus x1. So that means that my y2 is 3 minus my y1, which is 1, over my x2, which is 3, minus my x1, which is 3. 3 minus 1 is 2. 3 minus 3 is 0. Never can 0 be at the bottom. So remember that, guys. Next one. So just kind of explaining what slope is again. Definitely is your rise over run. Notice how your graph increases from left to right, meaning it has a positive slope. If it decreases from left to right, it has a negative slope, like if you're going downhill. If it's an undefined slope, it's vertical, so it goes straight up and down. If it's a zero slope, it goes left to right, meaning it's horizontal. Alright, so the building code for a ramp recommends the ramp should rise no more than 1 inch for every 12 inches of length. Does the ramp shown meet the building code, and how do you know? Well, what do you know so far? You know that the ramp is 8 inches and 70 inches long. And then you also know that the building, it cannot rise no more than 1 inch for every 12 inches. So what do we need to know? Does it meet building code? So we want to compare the fact that we know the building can be no higher and rise no higher than 1 inch for every 12 inches of length. We need to plan to find the slope. So think of it as rise over run. So in our case, based on our triangle here, our slope, we talk about rise over run. We rise 8 inches. When we think about our run, we run 70 inches. So when we simplify 8 over 70, we get 4 over 35, which is approximately 0.11. Well, remember, the building can be no more than 1 inch for every 12 inches. So our building can be no higher than 1 over 12. Well, 1 over 12 is approximately 0.08. Well, if we build this ramp, is it considered above or below the 1 out of 12 inches that we needed? 0.11 is definitely bigger than 0.08. So that means that it doesn't meet our code. Doesn't meet the building code. Because the fact that our slope for our ramp is going to be higher than what they said our ramp could be. So that's it, guys. Hope to see you all tomorrow. If you have any questions, please don't forget to ask them.